In this lesson, we're going to be finding the intercepts of a graph. And an x-intercept and y-intercept is simply where we're crossing the different axes. Intercepts are points where a graph intersects the x or y axis. So an x-intercept occurs where y is equal to 0. So you have an x-intercept, again, that's where your graph crosses the x-axis, and you can check that at both of these points my y values would be 0. A y-intercept, which is right here where it crosses the y-axis, would occur where x is equal to 0. And that's going to be very important that we remember those two things. A function can have at most 0 plus x-intercepts, but at most one y-intercept. What that means, 0 plus, it means that a function can have as many x-intercepts as it wants to. However, if a function or if a relation had two different y-intercepts, obviously that's not a function because you have a point above a point. But it can have as many x-intercepts as it wants. Okay, the examples below now, let's identify x-intercepts and y-intercepts, and this is going to be pretty easy because again, x-intercept is simply where a graph crosses the x-axis. A y-intercept is where it crosses or touches the y-axis. So therefore, my x-intercept here is located at this point, 1, 2, 3, 4, 0. And again, I'm going to put it as a point just to remind you that at an x-intercept that y is 0, and the y-intercept would be located here at 1, 2. So that would be the point 0, 2. So at an x-intercept, y is 0, at a y-intercept, x is 0. My next graph, we're looking for our x-intercepts. I have 1, 2, 3, 4 different ones. So my x-intercepts for this graph are, this is my origin. My x-intercepts are located at -1, at +1, at +2, and also at +3. So we had 4 different x-intercepts. My y-intercepts is just this single point right here, which is located at 1, 2, 3, 4, 5, 6. That's at 0, 6. And actually this thing would be a function. Even though I had 4 different x-intercepts, you can see there's no points above points. This is a function, which goes to show you that a function can have as many x-intercepts as it wants, but only a single y-intercept. Okay, the next one, x-intercepts, find your x-axis and see where your graph crosses. It crosses it twice at 1, 2, 3, -4, 0. And it crosses also at 2, 0. My y-intercepts would be right here where it crosses the y-axis, and that's going to be at -2, but it's going to be at 0, -2. Now, sometimes we will just list the number. We don't put the 0 with it, but again, just for the sake of you remembering, I'm going to list both. X-intercepts, this graph does not cross the x-axis, so there are no x-intercepts. However, we do have a y-intercept here at 1, 2, 3, 4, 5. That's going to be 0, 5. Number 5, x-intercepts appear here and here where it crosses the x-axis. That's going to be at 3, 0 and at 4, 5, 6, 7, 0. My y-intercept, find your y-axis and go down to where it crosses. It's going to be right here, 1, 2, 3, 4, 5, 0, -6. And again, you see at an x-intercept y is 0, at a y-intercept x is 0. The next one, we have an asymptote line. Now, it looks like it's going to cross the x-axis, but it does not. It levels off. Same thing up here. My graph comes down and looks like it gets closer, but it never touches it. That's an asymptote line. So x-intercepts, there are none. Y-intercepts, it does the exact same thing. It tapers off as it gets closer and closer to y, so there are no y-intercepts, so there are no x-intercepts on this graph, and there are no y-intercepts. Okay, next up we're going to be finding zeros, and this should sound familiar because a zero is a point where a graph crosses the x-axis. So what is a zero? A zero is an x-intercept. This is the exact same thing. Sometimes we call them zeros. Sometimes we'll call them solutions. Sometimes we'll call them roots. So make sure you know all these words. So anytime they ask for a zero, a solution, an x-intercept, a root, we're actually looking for the exact same thing. Now we're going to be finding these now without a graph. We're going to be finding them algebraically. Now could I graph each of these and find them? Sure. But I want to be able to make sure that we can also find these algebraically. To find the zeros, we're going to set your y equal to 0, or f of x, same thing. We're going to set y equal to 0, and we're going to solve for x. To find the y-intercept, we set x equal to 0. We've already said that at an x-intercept, our y equals 0. At a y-intercept, our x is 0. So here it says find the zeros and find the y-intercept for each function algebraically. So to find your x-intercepts, let's do it like this. To find my x-intercept, I'm going to set y equal to 0. And I have y equals the negative absolute value of x minus 5 plus 3. And we're just going to solve it. I'm going to move my plus 3 over. Now this is an absolute value equation. We've already solved these. You've got to isolate the absolute value, so move the 3 over by changing it to negative 3. And here's what you now have. You then divide by this negative 1, and it gives you 3 equals the absolute value of x minus 5. Once you isolate it, you then split it. So we're going to split it into x minus 5 is 3, x minus 5 is negative 3, and you're going to solve for each. Move the 5 over, gives you x is 8. Move the 5 over, gives you x is 2. These are your x-intercepts. And a good way to remember that is you're left with x equals. So that's going to be your x-intercepts. Next up, to solve for your y-intercept, you simply set x equal to 0, or you find f of 0 is pretty much what you're doing. Plug in 0 for x. So that's going to be negative absolute value of 0 minus 5 plus 3. Step 1, make sure you evaluate the stuff inside the absolute value first. That's going to be negative 5. When you take the absolute value, you now have negative, and the absolute value of negative 5 would be positive 5 plus 3. Negative 5 plus 3 is a negative 2. So your y-intercept would be y equals negative 2. So your zeros are located at 8, 0, and 2, 0. Notice the y's are 0, and your y-intercept is located at 0, negative 2. Next problem. Let's find our x-intercepts first. To find an x-intercept, we plug in 0 for y. So you have 2x squared minus 7x minus 4 is equal to 0. This is a quadratic equation. It's also going to be a bottoms-up factoring or a slip and slide factoring. Let's move the 2 to the end. We have x squared minus 7x minus 28. I'm just going to factor it, then I'll put my 0 back in. Factor like normal, x and x, adds, multiplies, and that should actually be an 8 instead of a 28. I don't know why I put in a 28. So adds, multiplies would be a negative 8 and a positive 1. The number that you slipped, you now divide by. So that would be an x minus 4 and that won't divide, so we slide it back to the front. That'd be a 2x plus 1, and we set it back equal to 0 now. Solve each, and you get x equals 4. And x equals, subtract 1 divided by 2, you get negative 1/2. So my two x-intercepts are located at 4, 0 and negative 1/2, 0. To find your y-intercept, you plug in 0 for x, so you pretty much just find f of 0. And that's going to give you your y-intercept. So that's going to be, it's easy to do. Look, 0 minus 4, that's going to be it's going to be a negative 4. So 0, comma, negative 4. Notice with a quadratic equation, the same thing as a linear equation, all your x terms go to 0. So pretty much this constant out here when you're dealing with a linear or quadratic is always your y-intercept. Same way as if you got a line in slope-intercept form, the same thing happens. Okay, number 9, let's find our x-intercept. Find your x-intercept by plugging in 0 for y. So you have x to the 4th minus 5x squared plus 4, set y equal to 0. This is of a quadratic form, so we can factor it just like a quadratic. You have x squared times x squared gives you x to the 4th. Adds, multiplies is a negative 4 and a negative 1. Now we could factor this again if you'd like. These are difference of squares. However, it's going to be just as easy, if not easier, just to go ahead and set each of these factors equal to 0. and solve it that way. Move the 4 over, gives you x squared is equal to a positive 4. Now here's the part a lot of people forget. To get rid of a square, make sure you do plus and minus the square root of 4. So you actually have two answers. Had you done difference of squares, you would have got the exact same two answers. Same thing over here, move the 1 over, gives you x squared is 1. So x would equal plus or minus the square root of 1, which is 1. So this thing's actually got 4 different x-intercepts. If you were to graph this, here's the reason why. It's actually going to be a W shape, and it's going to have 4 different crossing points. We'll talk more about those later. So your zeros are going to be negative 2, 0, positive 2, 0, negative 1, 0, and positive 1, 0. Your y-intercept, super easy. To find your y-intercept, again, you're going to plug in 0 for x, which means this goes to 0, this goes to 0, and you're left with just the positive 4. So your y-intercept, when you plugged in 0 for x, gave you 4. So that's where it's going to cross the y-axis. Number 10. Start out with your x-intercepts. To find an x-intercept, you're going to set your y value equal to 0. So x to the third minus 6x squared minus 7x equals 0. Took out f of x, plugged in 0. Let's try to factor this. Every term has an x. Factor that out first. That's your GCF. Leaves you with this. That will factor farther. Let's take and divide this into two sets of parentheses. X times x is x squared. What adds, multiplies would be a negative 7 and a positive 1. Set each of these factors equal to 0, and it gives you x is equal to 0, x is equal to 7, and x is equal to negative 1. So this has 3 different x-intercepts, and they are, again, 0, 0, 7, 0, and negative 1, 0. And you can kind of figure out what this graph would look like according to its x-intercepts. So it crosses at 0, it crosses at negative 1, and it crosses over here at 7. And we'll talk a little bit more about the graph as we find the y-intercept. Find your y-intercept, you plug in 0 for your x. So we're going to find f of 0 to find your y, which would be 0 minus 0 minus 0, which is also 0. So your y-intercept, we should have knew that. If it has an x-intercept of 0, the y-intercept would have to be 0 also. So 0, 0 is your y-intercept. Now this graph would look something like this. It comes up, comes back down, and then it actually goes back up, and that's an x to the third. That's the normal shape of an x to the third graph. Number 11. And we're going to have the same basic shape on this one. Let's start out by finding our zeros or our x-intercepts. We're going to do so by taking each of these and setting our y value equal to 0. We're going to try to factor. There is a common, least common, or greatest common factor of x. Pull it out, you're left with 3x squared plus 13x minus 10. We're going to have to slip and slide on that. I'm going to come over to the side and do that. Let me do it in a different color. I'll do it on this other problem, just erase it. So that's going to be x squared plus 13x minus 30. Two sets of parentheses. Gives you x and x. Adds, multiplies would be a negative 3 and a negative 10. No, it wouldn't. Let's try that again, because that would give you a positive 30. We need a negative 30, so that has to be a negative and a positive. That'd be a positive 15 and a negative 2. We slip the 3, so now let's divide by the 3. This will not divide, so slide it back to the front. It's 3x minus 2, and this would be x plus 5. So therefore, we now have this factored. Leave the x, two sets of parentheses, 3x minus 2, x plus 5. Set each factor equal to 0, and you get 0. Set this equal to 0, move the 2 over and divide by 3, gives you 2/3. Set this equal to 0, and you get negative 5. So my 3 x-intercepts are 0, 0, 2/3 0, and negative 5, 0. And again, you could find this exact same information by a graph. You could graph this function, and you could actually just look and see where it crosses. Okay, now let's find our y-intercept, and we find our y-intercept by plugging in 0 for x. And again, pretty easy. 0 plus 0 minus 0 would be 0. So your y-intercept is at 0, 0. Again, the reason why, because it would be impossible for it to cross for an x-intercept if it didn't cross at the exact same place for a y-intercept. Number 12. Set y equal to 0 to find your x-intercept. So you have the square root of x plus 1 minus 2 is equal to 0. Isolate your radical by moving the 2 over. That's the square root of x plus 1 is equal to 2. To get rid of a square root, you square the other side, so that turns that into 4. Subtract 1, you get x is equal to 3. So my x-intercept is located at 3, 0. To find your y-intercept, we find f of 0. We're going to plug 0 in for x, so that'd be the square root of 0 plus 1 minus 2. Square root of 1 is 1 minus 2, and then we've got to subtract, which gives us negative 1. So 0, negative 1 would be your y-intercept.